Among the astronauts, Walter Schirra is charged with the special problem of studying the capsule environment. But there are some moments of rest for the astronauts. Here, they sit in a projection room and watch the films taken of their visit to the Atlantic Missile Range, Cape Canaveral. On trips like this, each man gathers information concerning his particular assigned area of individual study. He is then responsible to the rest of the group for this information. Grissom's area of responsibility is the flight control system, including the automatic pilot. Cooper's area concerns the ballistic flights with the Redstone missile. Shepard is concerned with tracking and recovery of the capsule. Glenn has the cockpit area. Carpenter, communication and navigation. And Slayton has the responsibility for knowing Atlas and all of its systems. The possibility that trouble may develop with the Atlas or the Redstone during the countdown or during the takeoff is looked squarely in the eye by the astronauts and the engineers behind Project Mercury. This booster was not a Mercury vehicle, but imagine the worst possible situation for the astronaut, that his capsule is now mounted on top of this Atlas. The escape rocket takes the capsule away from the booster. The tower separates. The parachute opens, and the capsule lands in the sea.
Success in a pioneer mission depends on optimal human performance. And performance...
This is the voice of Dr. Theodore Benzinger at the Naval Medical Center, Bethesda, Maryland. The astronauts each take their afternoon of sweating it out in this gradient heat calorimeter.
In a temperature as hot as it is in here now for him and will later be for you, 114 degrees Fahrenheit, your internal body temperature is protected by a physiological mechanism of very high power and precision.
In the submarine carbon dioxide chamber at Bethesda, the astronauts learn that space medicine and submarine medicine have common problems. Under emergency conditions, there is a danger of the presence of unusual amounts of carbon dioxide in the space capsule or submarine hull. After 2 hours in the chamber under 3% carbon dioxide, these men are tired. But they were convinced that they could function for quite a long time, at least long enough to make a complete orbit of the Earth and then to make an emergency re-entry and landing. But before a man's life is risked in space, animals will undergo the same operational stresses. The animal research program connected with Project Mercury is an important prerequisite to research with human beings in space. The NASA research which created the individually molded couch, was another step toward minimizing the hazard of injury during the Mercury mission. This is the same man, John Glenn, sitting in his couch under 14 Gs in the centrifuge at the Naval Aviation Medical Acceleration Laboratory, Johnsville, Pennsylvania. And this is Gus Grissom. The astronauts consider this experience as probably the most important phase of their space flight environmental training. Alan Shepard, as he takes the G-load of an emergency abort and landing. To be able to take this physical beating, these men must be conditioned like athletes. And the astronauts find that the physical discipline of underwater swimming is oddly effective in training toward a space mission. Navy Underwater Demolition Team 21 at Little Creek, Virginia, supervises the instruction of the astronauts. Al Shepard and Wally Schirra have just completed a half-mile swim by compass course to the beach. Underwater swimming, aside from being an excellent physical conditioner, accustoms the astronaut to a forced breathing discipline and closely approximates the condition of weightlessness, which will be encountered in orbital flight. Now, imagine, if you will, that you are watching the first Project Mercury launching at the Atlantic Missile Range, Cape Canaveral. At launch time, the manned capsule with its escape system is thrust into the sky by the 2 booster engines and 1 sustainer engine of the Atlas. At an altitude of about 50 miles, after some 2 minutes of flight, the booster engines are turned off and jettisoned. The sustainer engine continues its thrust toward orbital speed as the escape rocket fires, pulling the escape tower free of the capsule. Orbital speed will be achieved at about 100 miles altitude. Once in orbit, explosive bolts release the capsule. Separation rockets on the capsule fire, pushing the capsule away from the Atlas. Now the capsule automatic pilot rotates the capsule. If the automatic pilot fails to respond or becomes erratic, the pilot has controls to maneuver the capsule into proper orbital attitude. Through a periscope or through his window, the pilot observes the Earth below and the heavens beyond the horizon. Near the end of the 3rd orbit, when the capsule is several hundred miles west off the coast of California, the signal for re-entry is given. Retro rockets fire, causing the capsule to leave its orbital path. Now man and capsule fall, and meteor-like plunge toward the Earth. Plunging through the atmosphere, the heat shield glows white hot. The blunt end must be pointed in the line of fall. Below, patrol aircraft sweep the re-entry area with radar. At 10,000 feet, the main parachute extends, and a SOFAR bomb is released. The bomb, exploding some 3,000 feet under the ocean, provides an accurate fix. With this information, patrol aircraft and ships converge on the spot where the capsule is expected to land. When the capsule hits the water, the parachute is released and sea dye marker spreads out on the surface of the water. As the capsule floats in the sea, a signal light and automatic radio transmitter indicate the exact position. And so, before the Earth turns many hundred times, another booster will rest on the pad at the Cape. And one of the astronauts will ride here on the shoulders of Atlas. This unmanned Atlas booster and capsule proved in the flight test experiment named Big Joe that this vehicle could perform the mission. Capsule without escape tower rocketed to 100 miles and was thrust downward to re-enter the Earth's atmosphere at a speed just below the predicted re-entry speed. The capsule was recovered in the Atlantic Ocean. The tests will continue. The experiments and training will go on to put man into orbit. These are the astronauts. United States Project Mercury.